On a flat, empty plain near the Martian equator, a robot sat down in the dust and did nothing. It didn't drive. It didn't dig. It didn't go looking for life. NASA spent years building it, flew at 300 million miles across open space, and its entire job was to sit perfectly still and listen. For 4 years, that is all it did. And every sound that came back was blurred, not faint, not missing. Blurred, smeared out like a photograph taken through frosted glass. And the further a sound had traveled through the planet, the worse the smearing got. Nobody could explain it. It took 6 years and a paper published in 2025 to work out what was doing it. And the answer is that the inside of Mars is not the neat stack of layers you were shown in school. It's a graveyard. Buried in the mantle of that planet, right now, are the shattered remains of other worlds. This is how we found them. Start with the diagram everybody knows. Cut a planet in half and you get the picture from every textbook ever printed. A thin crust, a thick mantle under it, a dense metal core at the middle, 3 clean layers, one inside the other, smooth as an onion. That picture came from studying exactly one planet, ours. And Earth is the worst possible planet to learn this from. Earth's interior never stops moving. The mantle churns. Plates dive underneath other plates and get swallowed whole. Crust is destroyed and manufactured again on a conveyor belt that has been running for 4.5 billion years. Almost nothing down there is original. Ask what Earth's interior looked like when it formed, and the honest answer is that Earth threw the evidence away. Our planet has been overwriting its own hard drive since the beginning. Mars didn't. Mars is small, about half the diameter of Earth and roughly 1/10 of its mass. And small things lose heat quickly. The same reason a cup of tea goes cold long before a full pot does. Mars ran out of internal heat within about 1 billion years of forming. The churning slowed down, and then it more or less stopped. Which means whatever was inside Mars when Mars was young is still inside Mars today, in the same position, untouched. For 4.5 billion years. There is no other object like that within reach. Mercury and Venus may have frozen their interiors too, but nobody has ever put a seismometer on either one. Mars is the only rocky planet besides Earth whose insides we have actually measured. So here's the problem. How do you look inside a planet? The obvious answer is to dig. And the obvious answer is wrong by a margin that's genuinely hard to take seriously. In 1970, Soviet engineers on the Kola Peninsula started drilling a hole for no reason other than to find out what was down there. They drilled for 19 years. They built machinery that did not exist before they built it. And in 1989, they stopped at 12,262 meters, a little over 12 kilometers. They stopped because the rock reached 180 degrees Celsius, and at that temperature, it stopped behaving like rock. It started to flow, closing the hole behind the drill like wet clay. The site was abandoned 3 years later. 12 kilometers is the deepest hole humanity has ever made. The center of the Earth is 6,378 kilometers down. Kola made it about 1/3 of the way through the crust, not 1/3 of the way to the core, 1/3 of the way through the outermost skin. If Earth were an apple, we have not broken the peel. So drilling is out, on Earth, and very obviously on a planet it takes 7 months just to reach. There is exactly one place we have ever reached the mantle, and it took a loophole to do it. In 2023, a drilling ship called the JOIDS Resolution went to a spot in the middle of the Atlantic where a tectonic quirk pushes mantle rock unusually close to the seafloor. From there, they pulled up 1,268 meters of nearly continuous mantle core. The previous record was 200 meters. So the state of the art is this. We cannot drill to our own mantle. We can only find the one spot on Earth where the mantle has come partway to us, and even that took 60 years of trying. But there is a second way to see inside something solid, and you have already had it done to you. When you get an X-ray, nothing opens you up. Energy passes through you, and different tissues slow that energy down by different amounts. What comes out the other side is a map of what it went through. Planets work the same way. You just need a big enough source of energy and a quiet enough instrument. The energy comes from quakes. When rock fractures, it releases a pulse that spreads out through the entire planet in every direction. And that pulse comes in 2 flavors. The first is called a P wave. Primary, because it arrives first. A P wave moves by squeezing and stretching the material in front of it, pushing and pulling, like a slinky. That motion works in anything, so P waves travel through solid rock and liquid metal alike. The second is the S wave, secondary and slower. An S-wave moves by shoving material sideways. And sideways is a motion that liquids simply do not transmit. Push a liquid sideways and it slides out of the way instead of passing the shove along. So an S-wave hits a liquid layer and stops dead. That single fact is how we know Earth has a liquid outer core. Nobody has been down there. We know because there is a zone on the far side of the planet from every large earthquake where the S-waves never arrive at all. A shadow. And the size and the shape of that shadow tell you the size and the shape of the thing casting it. That's the trick, not seeing the interior. Reading the shadow it leaves in the sound. Do that thousands of times from earthquakes all over the world and the layers assemble themselves. Speed changes mark boundaries. Bending mark shifts in density. Shadows mark liquid. The onion diagram didn't come from digging, it came from listening. Which brings us back to Mars, and to a question that was genuinely open in 2018. Does Mars have quakes at all? It was a real risk. Mars has no plate tectonics, no grinding boundaries, no subduction zones, none of the machinery that makes Earth shake. There was a serious possibility that Mars was seismically dead, and a seismometer on a dead planet records 4 years of nothing. NASA sent it anyway. The lander was called InSight, and it touched down on the 26th of November 2018 on a plane called Elysium Planitia. The landing site was chosen for being boring, flat, stable, and free of rocks. Every other Mars mission wants interesting terrain. This one needed the opposite, because it wasn't going anywhere. Its main instrument was SEIS, the Seismic Experiment for Interior Structure, built largely by the French Space Agency. A robotic arm lifted it off the deck and set it directly onto the Martian ground, then covered it with a dome to shield it from wind and from temperature swings. SEIS measures ground movement by tracking the displacement of a pendulum, and its sensitivity is difficult to state without sounding like an exaggeration. It could detect the ground moving by less than the width of a single hydrogen atom. Then, it waited. The first marsquake arrived on the 6th of April, 2019, the lander's 128th Martian day. It was far too small to reveal anything about the interior. It only proved the planet was alive. It's worth saying what a marsquake even is, because it isn't an earthquake. On Earth, quakes come mostly from plates grinding against each other. Mars has no plates. Its quakes come from the planet slowly cooling and contracting, the crust shrinking and cracking under its own contraction, and in the volcanic regions, from magma still shifting around underground. Mars isn't shaking because it's alive. It's shaking because it's alive. It's shaking because it's still cooling down. By the time dust on the solar panels ended the mission in 2022, SEIS had recorded 1,319 marsquakes. The largest, in May of 2022, was a magnitude 5. On Earth, that's a quake that rattles windows. On Mars, that is close to the biggest event the planet is thought to be capable of producing. And we happened to have an instrument sitting on the ground to catch it. SEIS wasn't the only instrument doing this. InSight also carried RISE, the rotation and interior structure experiment, which did something completely different. It just sat there and let Earth track its radio signal very precisely for 4 years. The point was to measure how Mars wobbles as it spins. That wobble depends on how mass is distributed inside the planet. Watch the wobble closely enough, and the interior has to declare itself. And in 2023, that radio tracking picked up something nobody had ever measured on another planet, Mars wobbling from liquid metal sloshing around in its own core. It also found something stranger. Mars is speeding up. The planet's rotation is accelerating, shortening the Martian day by a fraction of a millisecond every year, and the cause is still being argued about. The waves from those quakes did exactly what waves do. They arrived at different times, at different speeds, from different directions. And out of that, the interior of Mars assembled itself for the first time. Before InSight, estimates of the Martian crust range from about 20 kilometers to about 100, depending on which assumptions you trusted. That is not a measurement. That is a shrug with numbers attached. The seismic data narrowed it to somewhere between 24 and 72 kilometers and showed it comes in sublayers, much like Earth's crust does. Below that, a rocky mantle running down to roughly 1,560 kilometers. And then the core, iron, nickel, and sulfur, with a radius of about 1,830 kilometers. The crust also turned out to be lopsided in a way Earth's is not. The northern hemisphere of Mars is low, flat, and thinly crusted. The southern hemisphere is high, heavily cratered, and much thicker. The boundary between them runs most of the way around the planet, and the difference in elevation is measured in kilometers. It's called the Martian dichotomy, and after decades of work, nobody agrees on what caused it. That number is bigger than anyone expected, and it carries a consequence that took a while to sink in. A core that size, at that density, is fully molten. Not a solid center with liquid wrapped around it, the way Earth is built. Mars has no solid inner core at all. The middle of Mars is liquid metal, all the way down. And here is why that conclusion is hard to argue with. The seismometer put the core at about 1,830 kilometers by timing waves. The radio experiment put it at 1,835, plus or minus 55, by watching the planet wobble. Two instruments, two methods that share nothing in common, landing on the same number. But none of that is the strange part, because underneath every one of those measurements was the thing nobody had explained: the blur. Go back to those waveforms. When a marsquake signal reached SCIS, the low-frequency part of it showed up when it should have. The high-frequency part, the sharp detail, the crisp edge of the pulse, arrived late, smeared, and the delay wasn't fixed. The further the wave had traveled through the mantle, the worse the smearing got. A clean layer does not do that. A clean layer slows a wave down, or bends it, and the wave comes out the other side intact. Something was scattering the sharp parts of the signal, over and over, all the way through. In August 2025, a team led by Konstantinos Charalambous at Imperial College London published the answer in the journal Science. The Martian mantle is not uniform, it is not smooth, it is not layered, and it is not clean. It is studded with fragments. Scattered through the mantle of Mars are countless regions where the composition, the temperature, and the structure are all different from everything surrounding them. Some of them are up to 4 kilometers across, and they are not native to Mars. They are what is left of the things that hit it. 4.5 billion years ago, while Mars was still assembling, it was struck by objects large enough to melt continents, asteroids, protoplanets. Whatever else was still loose in a solar system that hadn't finished sorting itself out. Those impacts released enough energy to turn enormous areas of crust and mantle into oceans of molten rock. And the debris, pieces of the impactors themselves, was driven down into that magma and mixed in. Then the magma cooled, and the pieces were locked in place. Charalambous described the pattern as looking like shattered glass, a few large shards and a great many small ones. They have been sitting there ever since, unstirred, unrecycled, unerased, for 4.5 billion years. And every marsquake that crossed that mantle scattered off them and arrived at InSight slightly out of focus, which is why the sound came back blurred. That was the answer the whole time. The planet wasn't distorting the signal, the wreckage inside it was. There may be a second piece of evidence from a completely different method. Mars has a region called the Tharsis Rise, an enormous volcanic bulge that includes Olympus Mons, which stands nearly 22 kilometers above the surrounding plains. Volcanic rock is dense, so Tharsis should be pulling hard on anything passing overhead. Instead, it sits far higher than it should, ringed by a band of unexpectedly weak gravity. In 2024, a team led by Bart Root at Delft University of Technology mapped Mars's gravity field using tiny deviations in the orbits of spacecraft. Their model points to a mass about 1,750 kilometers across, sitting roughly 1,100 kilometers below the surface. And it is light enough to be pushing the entire Tharsis region upward from underneath. Their suggestion is a plume of hot material rising toward the surface, which would mean Mars is not quite as geologically finished as we assumed. This one comes with a caveat. It was presented at a conference rather than published as a peer-reviewed result, and the cause is still open. But an interior that is lumpy and uneven is exactly the kind of interior that would heat unevenly. That's a thread worth pulling. Here is what makes this more than a fact about Mars. Earth was in the same neighborhood at the same time, being hit by the same population of objects. There is no reason at all to think we were spared. Our mantle should be studded with foreign wreckage too. We just can't find it. 4.5 billion years of convection stirred it in and smeared it out. Whatever struck the early Earth was folded into the mantle and blended past recognition. The scars are gone, not because they never happened, but because our planet is still moving. Mars kept its scars because Mars stopped moving. And the same logic now points outward. If a rocky planet without plate tectonics preserves an interior like this, then Mercury and Venus, neither of which recycles its crust, may be carrying the same wreckage right now. Nobody has ever listened to either one. Which leaves a question the paper doesn't answer and can't yet. Earth's interior kept churning. Mars's didn't. Mercury's didn't. Venus went its own way entirely. 4 planets from the same cloud of dust over the same 4.5 billion years, and only one of them ended up with plate tectonics, a stable magnetic field, liquid water on the surface, and us. We don't know whether those things are connected, but we now know the answer is written in the part of these planets nobody can see. And for 4 years, on a flat, empty plain near the Martian equator, a robot that did nothing but sit still and listen brought back the first page of it.